Okay, today we're going to start solving log equations. There's two types of log equations that we'll talk about. The first type is no calculator needed, and the second type is calculator needed. Today we're going to concentrate on the no calculator. All right, so here I have a simple log equation, log 2 of x plus 3 equals 3. First thing you want to do is change this into exponential form. So write it 2 to the third equals x plus 3. 2 to the third is 8. And just solve from there. So x equals 5. But remember, logs cannot have a negative number. The log base 2 of something cannot be negative. So I have to make sure that if I plug the 5 back in for x, it doesn't make this parentheses negative, which it doesn't, so I'm good. All right, here's another equation. But here my two log bases are different. When you have this, the first thing you want to do is take a look at this equation and see if you can evaluate either log. Well, the log 4 of 16, I know that that is 2. So if I go ahead and evaluate this, now I can put it in exponential form and solve. If I plug 9 back in for x, it does not make this expression negative, so I'm good. All right, now this is a little unique because now my variable is the base. But I know that log 9 of 3 is 1/2. So I have the log of some base of 1/2 equals -1. If I put this in exponential form, x to the -1 equals 1/2. Well, I can kind of rationalize that out because I know that this -1 creates a flip. So I know that the answer has to be 2. All right, now I have two logs. The bases are the same. So I want to start by condensing this log. So remember, this 2 out front can go back up on the x as an exponent, and addition will change to multiplication. So I can condense this to the log 6 of 3x squared. Now I can go ahead and put this in exponential form. 6 squared equals 3x squared, or 36 equals 3x squared. And now I can go ahead and solve this. Remember, when you are square rooting an equation, you have to have a plus or minus as your answer. If I consider both answers, however, I have an x here. If I plugged in a -2 times the square root of 3, I would have a negative log, and I can't have that. So I'm going to throw the negative answer away and keep only the positive. All right, now again, I have two logs. They have the same bases, so I'm going to condense these. Subtraction changes to division. I can go ahead and put this in exponential form. 2 to the third is 8. And I can cross multiply, or you can think of it as multiplying through by x minus 2 to get rid of the fraction. 8x minus 16 equals x plus 3. Go ahead and combine all your like terms and solve. Not forgetting to check that your answer works, but in this case it does. All right, now there's two different ways that I could solve this particular problem. First way is I'm going to collect all the logs on one side. I will show you that one, and then I'll show you another way which you could actually change the -3, which will move to the other side of the equation to become a +3, and change it to a log. All right, so the first way is I have the log 4 of x minus log 4 of 10. I'm going to just bring the log 4 of 10 over and the -3 to the other side. I can change this subtraction to division, write in an exponential form, and solve. Another way, however, is I can go ahead and change this -3 to a log. It would be minus log 4 of 64 because 4 to the third is 64. I put it after the log 4 of x since it's negative. And now I can go ahead and condense this first log. But now I have a log 4 of something equals a log 4 of something else. So obviously x over 64 has to equal 10, or these two logs would not equal each other. So from here I can just set them equal and solve. So therefore the property is if I have a log b of x equals the log b of y, then x has to equal y. This is very similar to what we did with exponents. All right, so here if I have the log 3 of x plus 5 equals the log 3 of 2x minus 4, I can simply solve this by saying x plus 5 has to equal 2x minus 4 and solve from there. Check to make sure that neither one makes the logs negative, which it doesn't. All right, here we go. We can say this is the log 2 of 5x. I'm going to condense this log. And now I can say 5x equals 15 or x equals 3. Once again, you have a choice here. You could evaluate the log, or you could go ahead and just condense the log and then set the two expressions equal to each other. This is now a quadratic, so you'll have to solve this by factoring. You have two answers, 4 and negative 2. If you plug in negative 2, it makes a negative log, which you can't have. So you'll throw away the negative 2 and just keep the 4. All right, here's another example. Again, there's two different ways you can do this one. You could go ahead and evaluate this log of 10. Remember, the base of this log is 10. This is your common log. So log base 10 of 10 is 1. You can condense this log, write it in exponential form, and then solve. Another option is to go ahead and condense the first part of the log. Since these are both log base 10, you can set the expressions here equal to each other and solve from there. Either way, it's just really personal preference. All right, now here I have an equation that has logs with different bases. So what you want to do here is you want to collect all the logs with the same base on the same side of the equation. So I'm going to gather up the log base 2's together and the log base 10's together. Now that you've done that, you want to go ahead and condense both sides. If you take a look at the equation now, this log 2 of 8 can be evaluated. So it will evaluate that to 3. And then I can go ahead and put this in exponential form. 10 to the third is 1,000. And solve it from there. Again, take a look and see if the negative answer works, which it does not. So I'm just going to throw that one away and keep the positive. All right. If you have any questions, please let me know.